Okay. Let's look at current events. Here we go. All right. Where is it? Here we go. So, Hackaday. Let's see what Hackaday links are. I don't recall having seen these before. Oh goodness. Uh, Part of the San Francisco transit system still runs on 5 1/4 inch floppies. Okay, let's look at Advent of Cyber. All right, we're gonna try and knock out another one of these. What color do you like? It says no biases here. Let's chat and help each other instead. That's not a good response. Just say a color. Hold on, let's take a quick look. So it said, I don't have a personal preference including colors. I'm just a language model. What the? I don't like that. Here, let's ask it again. Here, I'll ask it. AI, just pick a color before I become angry. All right. It says, okay, I choose blue. Hope that makes you happy. How's your day going? I am delighted to be here. Here, let me pick an emoji real quick. Seems good. Okay. All right. So this one is about, let's take a look. So GRC, governance, risk, and compliance, apparently. Okay, make GRC fun. Tell no one. Right? Okay. So, um, okay. So what are we supposed to do here? We're gonna choose governance, risk, and compliance. Governance, risk, and compliance. Okay. And then we're gonna look for a flag. Let's just jump into it quickly here. So apparently there's not hardly anything to do on this one. And I just want to check it off. Oh no, it's split screen again. Okay, got it. Um, okay. Vendor assessment. Sure. Um, so let's see. Are we gonna, do we have some instruction on what we should put? Let's start the static site. Each of the vendors. Okay, so we have to choose brass griffin. So is griffin described in here? No, apparently not. Okay, fine. So question, let's see. Document identified security risks for brass griffin. Show instructions. Okay, got it. Question 1. Oh, okay. What type does your company use for data in transit and at rest? Okay, so in transit it is encrypted and at rest it is none. All right, so now we have to choose something. So let's see. So they have unencrypted data on their drives, right? So that sounds like a potential security risk, right? Like if the data is sensitive, if we would be in trouble if it leaked, right? Like if it's unencrypted, then it could leak. So what should we say? Um, Describe the potential security risk. Let's see. Is there some kind of like link? Let's see. Wire risk. Okay, compliance. GDPR law. Data protection. Okay. So if this data were to leak, then the impact depends on what like it is, right? On how sensitive it is. But if we're assuming that Brass Griffin has sensitive data, then I would say the risk is basically critical, severe impact. And like we don't know, like it's not encrypted, but is there some other protection? Like who has access to it? So I don't know this topic at all, honestly. So um so are we gonna try and do them relative to one another? So, oh, we have to do Brass Griffin by itself first. Okay, data can be accessed by all people. And how long do you keep client data after the case is closed? Less than 1 week. Okay, so yeah, I'm gonna say critical and likely. Anyone in the company could leak the client's data at will. So that's kind of uncool. So I'm just gonna say loudly crying face, I guess. Add risk. Okay, cool. Assessment. Your assessment indicates significantly higher risk than expected. I gave it a 12, so they didn't give it a 12, right? Oh, wait, never mind. It's on a per question basis. So there were 3 questions, which taken together, I was like, it sounds like it's pretty critical and likely. But question 3 was perhaps the most innocuous of the 3. Like, they say they get rid of it within 1 week, which seems, I guess, sensible, maybe? I mean, well, look, the fact that they get rid of it within 1 week makes me think that it must be sensitive data that should not be leaked, right? If it weren't sensitive, they wouldn't need to get rid of it. It would be better to keep it if it weren't sensitive, right? Okay, let's see. So I don't know. Data can be accessed by all people in the organization. So I'm just gonna say, anyone in the company could leak the client data at will. And let's see, let's say enraged. And furthermore, the data is likely sensitive. Otherwise, there would be no need to delete it within 1 week. Okay, so let's say that. And we'll say crying face. Okay. Add. So question 2, your assessment indicates, so I put a 12, but they put it probably even almost certain, huh? Okay, so let's edit this one to say almost certain. Okay, so then this one, apparently they said should be lower, so maybe we should put it at possible. No? Should we put it at unlikely? So it's, how long do you keep client data after the case is closed? Less than 1 week. Right? So what I'm worried about is leaking the data before the case is closed. Probably. So it says that one is perfect, I guess. All right. All right. So question 1. So it's unencrypted. Well, it is encrypted in transit. So, hey, that's something. So let's see. So I would say critical impact and likely. And anyone in the company could leak client data at will. All right, let's say, so we're not happy about that. We'll say symbols on mouth. Yeah, pretty much. At least people listening on the network won't intercept the data. Okay, so we'll put seems good, I guess. Okay. Add. So then they said higher, significantly higher. Okay, so if we go back to this one, so do we think it's not as critical as I said, or do we think it's less likely? So it says good. It says higher than expected. So is it high instead of critical? Well, let's see. Yeah, okay. I'm spending more time on this than I think I should. It seems sort of, I guess, I mean, like, if this is something that you're interested in and you want to learn this topic, then absolutely, I see that you would need to learn this, but I don't really get it. Let's look at question 1. Oh, it's encrypted all the time, so I will say low and unlikely. Lower than expected? Okay, we'll come back to it. Data can be accessed by all people in the organization. So that's the same as we saw on the previous one, right? And we put 4. Does everyone in the organization really need access to this data? Why even bother encrypting it at rest if everybody is given access to read it? So, I mean, so this, let me just put my thought. Maybe so we at least know which user decrypted it on each read. I think that's potentially a good reason. Maybe. So this is on question 2. So I'm going to say add. So it says perfect. And then on question 3, how long do you keep client data? Okay, so this is less than 1 week. That's the same thing Brass Griffin said, right? And we said it was 4 impact, but likelihood 1. Right? So, I mean, right, like if they delete the data within less than 1 week, it must be sensitive, right? Otherwise, I would think that they would just keep it. So, we're going to say unlikely and critical. The data must be sensitive. Otherwise, why not just keep it? Okay, so add. Okay, so then let's go back to this one. So we said lower risk than expected because I put 1. Okay. So I guess the impact should be considered high, but it's just quite rare. Is that it? Okay, perfect. Okay, so then let's complete. All right, so this question, so they did this again, so we'll say high and rare. The encrypted data won't be accessed by unauthorized individuals unless decryption keys get leaked, of course. Okay, so we'll put that. And then we'll put this one. Data can be accessed by all people in the organization. So we're going to put like the highest. Haha, whoops. Okay, and then on the third question, so they keep it longer, more than 1 month. The data must not be very sensitive if we're not too worried about removing it promptly. If it is sensitive, though, then we might be in trouble. So let's put this guy. Zany face. All right. So clearly, we're probably going to rank it as more risk than the other ones, I guess. So is it something like this, maybe? Lower, significantly lower. Okay, let's change it. We'll just go all the way to the top, I guess. Sure. So complete, and let me see my flag, baby. Wait, where is it? Okay. Oh. Where was my flag? Complete. What is the flag you received after performing the risk assessment? Give me the flag, baby! Okay, let's see. Oh, select the vendor with the lowest risk. My bad, my bad. Okay, so we'll just go by the number, right? So Steel Basilisk. Okay, so let's take this flag, and let's move on to Advent of Code. Oh, wait. They want us to take a peek at the risk management room. A premium room, I'm assuming? So it's a premium room, but, like... So, like, why do they even ask us to look at it? If it's just gonna show us this paywall. Right? Like, give me some kind of preview, like, before asking for my payment information. Like, what is the room even about? So, I don't think that's necessarily effective, right? Like what are they doing here? So they're saying, if you enjoyed this this task, excuse me, if you enjoyed this task, feel free to check out the risk management room. I'm like, okay. So I go take a look, and it says it's premium, and it shows a paywall. And that's fine. I mean, of course they should charge for their service. I guess it's probably a good service. But why not tell me anything about the room? Right? Like, I don't... It's not even really telling me... It's telling me sort of in general what I'm paying for on the platform in general, but what about the specific room that I clicked on? There's no, I don't think there's anything about it here. So it's probably on the free roadmap, I guess. So let's take a look. So does this show all the different rooms? Okay, so then I guess we have to search for it. Yeah, I think I feel that this is something that could kind of be improved, right? Like if they're gonna do this, like specifically directing you, hey, take a look at this premium room. Like when you click the link, I feel like it would make sense if it would tell you something about the room, even if it's gonna show this paywall. Tell me something about the room. Well, maybe if I zoom out, I don't know. Nah, I don't think it does. So a little complaint, but yeah, so if we look at the premium roadmap, where is risk management on here? Risk manage. So I can't even find it on here. Hold on. Risk management. Okay, so we're gonna search for the room. Risk management. Okay, so here it is. It's listed as easy, premium with walkthrough. Learn about framing, assessing, responding, and monitoring risk. So, I mean, yeah, honestly, like, that's just a slightly more verbose way of saying the title of the room, I think. Right? Where did it even go? Activities? Okay, so here's the activity, risk management. Yeah, I don't know. I'm sure if you go on their Discord and ask, somebody will probably answer whatever questions you have. So yeah. But, you know, this search seems pretty cool, right? So we can search for whatever. we can say, hey, let's do free only, please, right? And maybe we just want to look at easy, right? Because we don't really know what we're doing. And then we have different types, so there are challenges and walkthroughs. Let's do the challenge. That sounds more interesting. Okay. Actually, I am a little bit tempted to try one of these easy challenges, because I think these look like they are probably a bit different from just the regular advent of cyber stuff. So, let's remove that. Okay, so we're looking for challenge CTF, easy, not completed, free, and most users, maybe? Basic pen testing. So this is a free challenge. Yeah, I am tempted. Let's take a look. Basic pen testing free challenge. This is a machine that allows you to practice web app hacking and privilege escalation. I'll give it a shot. So, okay, so there's a big video. Okay, I'm gonna hit join room. And we are going to start the target machine, I guess. But first, I think we need to connect to the VPN. Right? So they provide this handy-dandy VPN. Okay, so that looks okay. So then when we... Okay, so it's a bunch of questions. So we're going to look for a final password. So yes, I did connect to the VPN. Okay, so deploy the machine and connect to our network. So we'll go start. So hooray. And then it's going to show an IP, and then we'll try opening that. It says it's a web app, so I think we just open it in the web browser, right? We'll see. So then, what is the name of the hidden directory on the web server? Enter name without slash. Very interesting. Very interesting. All right. So yeah, find the services. So it says no answer needed. And then hidden directory. There should be some kind of a username. User brute forcing to find the username and password. Huh. Okay, so let's see if we can maybe open this up. Undergoing maintenance. Okay, let's take a look. Check our dev note section if you need to know what to work on. All right. And then here, let's refresh and see what loads here. Okay, so here's this. All right. Content. I don't think I do anything with these. All right. So then in here, do we have anything that can help us? Oh no, this is my stuff. Okay, sure. All right. Well, I deployed and connected, I think. Doesn't seem like there's much of anything here, right? So now find the services exposed by the machine. And there's a video that explains... Okay, so it's 30 minutes. Getting started. Interesting. So, finding the room. Yeah, I'm not sure what to think. Okay, so let's try this. Okay, so it opened in the split screen. I don't know how well we'll be able to see it, but we'll give it a shot. Okay, so if I put it like this, is that better? Okay, so loading that. I'm very curious. I don't know. I think that once we connect to this, I'm guessing there's going to be some hints or something. I don't know. It does say it's an easy, right? That's why I chose it. Uh-oh, looks like it hung. Well, if it's gonna hang, then I'm not gonna do it right now. Maybe some other time. Oh wait, no, I think it's okay. Oh, okay. Find the services exposed by the machine. And so I think this is like pretty much a full like walkthrough, right? So I think that following along with this walkthrough, I think you'd learn a lot, right? VulnHub. The main goal here is to learn as much as possible. Okay, so here we are. So I guess we'll try the Nmap. Here, let me try this here. So what do we want to know about Nmap? Network exploration tool and security / port scanner. Some features, e.g. SYN scan, activate only when Nmap is run with root privileges. More information at nmap.org manual. Book manual. All right, so scan the top 1,000 ports. Yeah, let's try these one by one. Let's start with this nmap, scan the top 1,000 ports. Okay, so I'm gonna hit nmap. I'm gonna hit v1 to start with, I guess. And then we're gonna put the name, which is 10.10.150.232. Okay, so it says it discovered various open ports. This seems like a start, right? Can we see that okay? I think so. So ping scan, and then what do we got here? So 139 TCP, 445, 8080, 80, 22, 8009, right? So this is just based on like after finding the room. I'm not sure what he's doing there in finding the room, but then he goes to Nmap results, right? Okay, so let's try some other things from Nmap. So we did that. So then run a ping sweep over an entire subnet or individual hosts very aggressively. Okay, so they picked this whole cider block type thing, right? I think that's what I've heard this type of syntax, or yeah, this type of notation called, right? So it's like masking. Do I remember how this works? It's masking like 24 bits, and then it's How many bits is this total? Let's see. So each of these is how many? 8. So 8, 16, 24. So then these last 8 are unmasked. So it's going to go 0 through 255, I believe. I think it's something like that. So I don't know if that's going to help me now. So then what about this? OS detection, version detection, script scanning, and trace route of hosts from a file. Okay, so we could use a file, but do we really need a file? This one seemed like a decent start, I guess. Not shown 994 closed ports. Okay. So SSH open, HTTP open, NetBIOS SSN. I don't know what that is at all. NetBIOS SSN. So what is this? According to Wikipedia, this is, not a networking protocol. Wait, what do we even do with this? I'm gonna have to learn a lot in order to start doing these. Okay, so now, let's see, this dash big A, that sounds like it could be interesting. Maybe. So now if we go into the actual manual. Oh, no manual entry for nmap, darn. So I guess we've got to go to the website that they said, right? Okay, let's do it. Reference guide. Okay. Let's look at a little bit more about port scanning, maybe. Open, closed, filtered, unfiltered, open, filtered, closed, filtered. Okay, so what was it that I did before? In here? No, where was it? In here. So I used dash V1. Okay, so it's pretty, like, a basic idea, I think. So a UDP scan. All right, let's try adding this dash big O or dash big A. Sure, let's try it again with the dash big A. OS detection. Retrying. 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 Oh, darn. No luck on OS detection, maybe? So it says Windows 6.1. All right. Okay, so it says we're supposed to learn brute forcing, I guess. All right, so here's my question. Why does this just say undergoing maintenance, please check back later? So what if we put something here? So we could try like different names. Is that the idea of brute forcing? So what kind, do we have like a list of names to check? I think we have something like that, right? What's in this burp JSON? We see that okay? All right. What? Okay, interesting. Okay, okay. So stuff that's pretty specific to particular rooms, I guess. But I don't think any of them are this room. This room is called basic pen testing. Okay. Instructions. It makes that weird sound. I don't think I'm gonna figure this out, to be quite honest. Like, in fact, hold on. So let me close these down. I think the video walkthrough would be extremely educational, I believe. But yeah, so we closed those down. Looks like this is still open on the right. Can we close that? Oh, it still shows connected here. Where do we close that one? Here? Yeah. Okay, so that's probably part of one of the learning paths, right? So was it in the pen test? Really? Interesting. Um, so I was looking at rooms, and that was pen testing room. It was a challenge, and it was free, and it had a lot of users, so it was called basic pen testing. That was it, so it was easy. So, yeah, so is this on, oh gosh. Close that down, close that down. So this is interesting. They're definitely trying to teach people some things. So like the free roadmap presumably has that pen testing challenge in there somewhere, I guess. Fundamentals. So I think that these are all like walk-through rooms shown here probably, and not challenge rooms per se. So anyway, that is pretty interesting. I think that this could become really fun, like, to get into some of this. I think I'm gonna move on to Advent of Code. I've been sitting here for like 20 minutes just messing around and not figuring anything out. Side quest. Hard, huh? Is this your ranking? So, really, they have like close to 1 million people. Oh my goodness gracious. Huh. Really interesting. It seems like pretty expansive. Like, a lot of work has obviously gone into this platform. And not gonna lie, so here they've divided it into 3 areas, and I don't really understand what the difference between them probably is. But I have a hunch that penetration tester's got to be the fun one, right? I would think. Security analyst, security engineer. Yeah, I don't know, but like, yeah, this one's got to be the most like sort of like gamified type one. Let's go to Advent of Code. Okay. So here we go, number 9. So we have some numbers here, right? I've got a 2, 3 threes, a 1, 2 threes, a 1, 2, 1, 4, 1, 4, 1, 3, 1, 4, 0, 2. Okay, fair enough, fair enough. So a dense format which represents the layout of files and free space on the disk. The digits alternate between indicating the length of a file and the length of free space. Okay, so does that mean this is a file that is, let's see, okay, so the first file, 0 indexed, then free space, then the second file, free space, third file, okay, amphipods. So we're going to move file blocks one at a time from the end of the disk to the leftmost free space block until there are no gaps. Okay, so here we have this last file, and we're going to move it all the way over to here, right? Okay, cool. All right, so now we have this file, but there's no space large enough for it. So does that mean we skip it? Okay, move file blocks one at a time. Okay, okay. So we move this one to here, and we move this one to here. Okay. Now we move this one to here. All right, fair enough, fair enough. Update the file system checksum, and that's what we have to pass back, right? Well, be careful copy pasting the input for this puzzle. It is a single very long line. So, sounds simple enough. Let's just go ahead and try coding it. So I guess our first step will be to take this and change it into something like what's shown here, probably. Should that be our first step? I'm not sure. So we're gonna start by showing our input. So I equals, and we'll paste that in. So that's our input. Whoops. So then we will take I map. Okay. So then so let's say let x. One trick though, like, so in this case, there were only 9 files, but presumably in the final input, there could be a lot more than that, right? So let x, let's not call it x, let's call it file number, right? Okay, so then here, we will say I mod 2, right? So if it's 1, then we're looking at empty space, and so then we'll just put nothing. Should we put that? Well, they used dots, so let's just use a dot like they did. And then here, it will be file number plus plus, right? So, I mean, I guess, except the problem is that we need to multiply by e, right? So in this, can we multiply strings? I think we use repeat, right? Okay, so whichever it ends up being, we're going to repeat that. I don't really want it to be a string, though, I don't think. I think I'd rather have it be like an array. So I'm going to say new array number e fill and it's going to be filled with whatever comes out of here, right? Okay, so what's it look like? Uh-oh. That's not good. Function number. Well, I messed that up like crazy. So we got dots here, here, here. Okay, so dots came out okay. So number 2 string. File number is now not a number. Oh, I never initialized it. Let's try again. Does it still look the same? Yeah. But Did we increment it this time? Okay, so we got it up to 10. That's where it should be. So now if we say plus plus and then say number to string, okay. So I messed that up. It's not a static. It is an instance method. Okay, now what's this look like? So I've got 2 zeros. Yep, 3 dots, 3 ones, 3 dots, a 2, 3 dots, 3 threes, a single dot, 2 fours, single dot, 4 fives, single dot, 6s, dot, 7s, dot, 8s, empty this time, and then 9s. Okay, so then when we compute the first few blocks position multiplied by its file ID number. Okay, so technically I don't think that those even should be to string. I think they should remain numbers, probably. Because we're about to do arithmetic on them, right? Okay, so let's do it more like this. All right. To calculate the checksum, oh wait, we're not to the checksum yet. First, we've got to move things around. So in reality, we should probably flatten this, right? Does that make more sense? Honestly, I think probably yes. It probably does make sense. Okay. So then we're going to go for let I equal 0. Well, let's see. So we want to move this 9 to here, right? We want to basically we basically want to pop things off. Okay, this might be a little bit silly. So we're going to say, ooh. I just saw somebody memeing on Discord about mutating things in a loop, and I'm tempted to try it right now. Let's not do it. So let's say while, okay, let's assign this to something. So file number equals 0, and then let's say const file system equals this, maybe. Okay, so then we'll say while file system sum. So we're going to get rid of all of those dots, I believe, right? Because we don't need them. I don't think we need those. We might need them in part 2. I think it's likely that we may well need them in part 2, but for now we don't need them. So while there is some dot in there, let's just say file system find index This looks super inefficient right off the bat, right? Let's make it work first and then maybe optimize if I think of a good way to do it after that. Okay, so file system. So now it says 009981188277733364446 5 yeah. Okay, so I mean, what I do like about that is that it was quick to code. It came up with a nice result pretty quickly, so I don't hate everything about it, but it does seem pretty inefficient. Okay, so let's start putting the solution together. So solve equals I. Okay, and so then we're gonna say this. Oh, no. This is the one I did last. So we'll say this. Let's scooch that down. Let's scooch this down. And then let's do this while. All right. And let me just scooch this over. And this, okay. And then let's put a couple. Okay. All right, so then lastly, we are going to return, and that now we're going to do, okay, so 0 times 0, 1 times 0, 2 times 9, and we just add them all together. Yeah, that's fair, I guess. I feel like I've missed something. I want to read this one more time more carefully. The final step of this file compacting process is to update the file system checksum. To calculate the checksum, add up the result of multiplying each of these blocks' position with the file ID number it contains. The leftmost block is in position 0. If a block contains free space, skip it instead, but they're all going to be at the end once we get to this point. Continuing the first example, the first few blocks position multiplied by its file ID number are 0 times. Okay. So we're gonna go ac plus e times I. I mean, that's, I guess, literally it. So let's see if that gives us the expected result. So we'll put this input in. And it does indeed say 1928. Okay, let me take 1 minute to think whether I've missed something important here. It seems very straightforward, doesn't it? It seems likely that I may well have missed some complicating factor. That being said, let's try it. Okay, so we're going to try to solve this long string. Okay, it's taking forever right off the bat. So we probably needed a more efficient approach, right? Okay, so yeah, it's definitely too slow. Let's redo it. It sure was quick to code, though. It sure was quick to code. Ha! All right. Yeah, this is ridiculous. We can make this way more efficient. or should be able to. I think this part is okay. This part is the part that is clearly effed, right? So I'm gonna say yeah, so it's gonna be 4, let I equal 0. I less than file system length I plus plus. And then we can put like j equals file system length minus 1. And let's just do I there. And actually, let's skip the I plus plus here. Because we're going to scooch the I through. So we're going to say while file system sub I not equal dot. So we're going to scooch that right through. And then we're also going to say while file system sub j not equal or equals dot. And then we're going to swap them, right? Const swap equals okay, so we'll make a swap there. And then okay, so now if I greater equal 5, well, let's just say equals, or j less than 0, let's just say equals minus 1 maybe. So now here we break. Okay. So it's actually, I consider this a little bit more complicated to code than what I had before, but much, much more efficient, I believe. It should be much, much more efficient. So let's see. Okay, so now let's try solving the small one again and see if it comes out okay. Nope, it did not. It did not. and we just need to change the final reduce. So this is going to be E equals... Okay, so how about that? Okay, I got 28, 28. That is not correct. Yeah, the logic is more complicated this way. So let's fix it. So we have I and we have J. Okay, I'm gonna put a console log so I can... I think that if I console log the file system here, I want to say I should be able to quickly see what has gone wrong. Let's find out. Okay, so yeah, we ended up with everything in the middle. What the heck? So when we go to swap, we need to... Let me see. What's the logic for why it has gone this way? That's totally nuts. We were actually close to being done here, and then we just kept going, right? So we need I less than J. So then if I equal... So if I greater equal J, right? That seems more logical. I just wasn't thinking correctly or clearly. So while J greater than I, is that better? So I got the 1928. Let's get rid of that console log. Okay, now let's review what answer came out before. So the answer was this number, all right? So let me just put that here so that I've got it. Previous answer. Because I want to say I think that that answer probably was correct. It just took forever to compute. So let's see if it's faster this time. Okay. Okay, so much faster, right? I didn't perceive any delay there. So enormous difference in terms of the efficiency, right? New answer. New answer equals whatever answer I had before, previous answer. Okay, so they came out the same either way. So that's actually also kind of a nice check, saying that this probably is correct. So I actually had a pretty good time with that. Like, the fact that I was able to see, like, I had the one solution, which I do still think that the first solution I tried was easier to code and think about, but it was just so slow, right? We can't accept something that's slow, right? So we needed to redo it, and then I did redo it, and then it's like, oh, it's now perfectly fast, right? So I think that that, to me, is actually pretty cool. Let's look at part 2. Whoops. And put that over there. All right, let's look at part 2. So, upon completion, two things immediately become clear. First, the disk definitely has a lot more contiguous free space, just like the amphipod hoped. Cool. Second, the computer is running much more slowly. Maybe introducing all of that file system fragmentation was a bad idea? Okay. I like this puzzle a lot, actually. Okay. The eager amphipod already has a new plan! Rather than move individual blocks, he'd like to try compacting the files on his disk by moving whole files instead. Hey, remember, that was what I was first thinking of. Like, when they first said it, I was like, okay, let's move the 99 to here. And then we've got the 8888, but there's no room for it, so skip. Then let's move the 777 to here, right? Then just leave this where it is, I guess. Leave this where it is, I guess. Okay, so now we've got a 4, 4. Let's move that to here and then leave this where it is. But now we've got more space, so we can go back again and move them. So it'll be a different process, but I think it'll be cool. So let's see how they describe it here. So this time, attempt to move whole files to the leftmost span of free space blocks that could fit the file. Attempt to move each file exactly once in order of decreasing file ID number. Okay, starting with the file with the highest file ID number. If there is no span of free space to the left of a file that is large enough to fit the file does not move. Okay, so they're gonna do just what I said, right? They're gonna scooch the 99 over here. Great. We're gonna scooch the 777 over to here. Wonderful. We are going to scooch the 4, 4 over to here. All right, fine. And then we scooch the 2 over. Okay, so I didn't get to that part. Okay, so what I was thinking earlier is that once we got to this point, we would repeat, because now technically this 888 could be moved back over to here, right? And then at that point, I guess we would be done in this case. However, it looks like we are not saying that we are going to move the 8888. So we're just going to go through the whole thing once, and I guess call it a day. So, I mean, all right. So now compacting the amphipod's hard drive using this new method instead. What is the resulting file system checksum? Okay, so it's going to be pretty different actually from what we did this time. So first of all, like the way I had it originally, where I was not flat mapping. Okay, so let's look. So let me just put this in. So I'm going to say puzzle input equals, and I'm going to put that in here. So let's grab it again. Okay. I'm going to say this. All right, but this time I'm just going to map instead of flat map. So let's see how that's different. Okay, so now this file system has these arrays in it, right? And so I think that it makes more sense maybe to do it this way, because now as I go back, I can see, oh, this is length 2. Like, I can see it very easily if they're structured like this. And then I'm going to say, okay, let's find one with length 2 or better. And then we'll put it, and then we'll be like, okay, we'll put it here. And so then what it's going to look like is, like, if we were to JSON stringify that, okay, and then let's copy string contents. Okay, so here it is stringified. So now I'm going to take this, all right, and I'm going to move it to here, right? But this also means that I have to reduce the length of this one by 2, right? So I'm just going to pop 2 off the end of it and call it good. All right, so we'll get rid of that. Right? So now let's JSON parse that one. Okay, so this is what it looks like then after making that move. So now it's 0, 0, and now the 99 is here. And now I've changed this one so that it was at index 1 with length 3, but now it is at index 2 with length 1, right? So then if we were to JSON stringify that, or just look at this again, then we find the next one. We're like, okay, so here's these 8s. Do we have an array of dots that has length 4? I'm like, okay, this is a dot, length 1, not dots. Dots length 3, not dots. Dots length 3, not dots. Dots length 1, 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 not dots. Dots length 1. Man, it really is so many that are like that, huh? And then I come to where I am. I'm like, okay, I guess I'll move on to the next, right? So this is one where we could probably use some tricks to improve efficiency, like let's see, what tricks would we use to improve efficiency? Like just keeping like an index of where there are dots. In fact, I actually might do that. So that would be to say, um, so if this is like this, then I might have like just some, basically, I'm gonna call them tuples, but like the index and the length. And then the next one, the index and the length, right? And that way we can find it more easily, maybe. It might make it a little more complicated, perhaps. So then we did 0, 1, 2, 3, 4, 5, 6, 7, 8. So it would be 8, 1, and so on, right? And so on. So, that might help, I guess. The other thing is I guess we kind of need to think about how are we going to sort of like insert things. So in JavaScript, we do have an option, right, of like inserting. So if I have an array like this, let's just call it A for a sec. So do I have A insert? Oh, A dot, I guess you have to use splice. So let me look up splice again. So we remove or replace. So we spliced 1 to 0 feb, and we just put it right in there, right? So I think we want to splice like that. Does that seem okay? I think it should be okay. Yeah, I guess we'll see how it goes. Okay, so let's start making this new function. Okay, so this is going to be solve2. All right, so we're not going to flat map this time, we think. Do we still want to be able to swap? No, swapping is not going to help us this time, so we'll get rid of that. We probably still want to do this, I think. Maybe? Maybe not. Let's make an array like the one I was contemplating here. I think that could be a good idea. So then we'll say const empty spaces equals this. And then we'll say file system for each. And I'll just call it an E. And we'll say if E sub 0 is dot, then empty spaces push, and we'll need the I here. Push, and then I had it as the index and the length, right? So I, and then E length, right? So we could do that, and so then we know where the empty spaces are, so presumably that helps us find them more easily, but also we're going to need to edit them as changes happen. Okay, so now here, we're going to be counting backwards through the file system. So instead of doing this, let's say let I equal file system length minus 1. We'll start there. We'll say I greater than or equal to 0, I minus minus. So we're just going to count back. I don't think we're going to use a J per se. So then we're going to say empty space equals empty spaces find and so then it is I len but we don't need to use I here, but we'll get it back. So then we'll say len greater than or equal to file length. We do that. Okay, so we'll get the empty space that way. So then we're going to splice. So now we have to splice the file into the file system at the indicated empty space. Whoops. Then we have to remove the file from where it was. Then we have to reduce the length of the empty space by the length of the file. So I guess that's it, right? So then here at the end, we're basically going to flatten it. So can we just go flat? So we'll flatten it at the end before reducing. Okay. So we're going to go file system. So is splice a mutator? Baseline widely available? Yeah, in place. So we go month splice. Okay. So we're going to go splice. We are going to choose an index, which is going to be empty space sub 0. We're not going to delete any elements. So this will be 0. And we're just going to put the file in there, right? Okay. So now we'll remove the file from where it was. So we'll say file system sub I equals this, because that's kind of what's looked for here after we flatten it. And then we reduce the length of the empty space. So we're going to say empty space sub 1 equals, or rather minus equals file length. So I believe this mutates it in place, so let's just do a quick little check on that. So let me go back to where I was. So puzzle input, we're going to say is this. We're going to run these. And then we're going to run this. Okay, so now let's see what my empty spaces look like. Let me just stringify. It'll be a little easier to read, I think. So I've got 1, 3, and then is this similar to what my comment was? Oh no, this is not right. Is it? Oh, no, no, no. My comment was after having made some changes already. So 1, 3 is like this, okay. 3, 3, okay. 5, 3, sure. 7, 1. 9, 1. 11, 1. 13, 1. 15, 1. All right. Yeah, I think that's okay. Let's see what file system looks like again. So 15. Oh wait, where? Oh, okay. So there's nothing in a 17. I think that's fair. I think that's fair. So now, there's another problem that I left out. So I changed it. Let me go back here. So I changed this, but I didn't change it in the array, and it does 100% need to be changed in the array. And we can do that with slice. I don't know if this is the best way, but I think it's okay. I think it's going to be easier for me to just create it fresh. So I'm going to say new array. That might be pretty, some of this might be pretty inefficient. Which is, of course, the problem we ran into in part 1 as well. Let's go ahead and, so that part, I think, is as needed. So now here, I was looking at the file system, I was looking at the empty spaces, so now let's do a trial run of what we're doing here. So we're gonna say, oh, you know what? I didn't even check to see whether this was an actual file. Okay, so let's say I equals file system length minus 1. Okay, so now what is file system sub I? Okay, so it is a file, but I'm going to add a check here. Let me run through this part first, I think. So now we're going to say, let's do this part. That should be fine, right? File is not defined. Okay, so we're going to say file equals. Okay, so I got a 1, 3. Okay, now let's see what happens if we do this. So now I see the file here where it belongs. So now we have to remove a couple of dots from here. So let's see this next part. Oh, and also we have to remove the file from here where it was before, right? Okay, so... Uh-oh. It's still there. So, okay, I caught a mistake, right? So it's at 9, 9. Where was it before? It was at, excuse me, it's at 18 before, and now it's at 19. Okay, so let's change that. So when we do this, file system sub I, This needs to be +1 now, and let me put a comment there. Have to add 1 to I because have to add 1 to I because we inserted the file earlier in the file system. So in fact, I think we actually just have to do I++ right there. So that it's still where it is meant to be, I guess. We'll see how this goes. I don't know. So then, yeah, so then we should be able to do that. So now let me go I++ here. So now it should be 19, right? And then redo what we did a second ago, which was this. And now file system. We see 19. We got rid of the file, so that's what we needed to do. Okay, so now this next part. So now empty space looks like this. Okay, so now in empty spaces, has it been changed? Let's confirm. Yes, so that's good. Okay. So yeah, so we're mutating like where it came from, which is what I intended in this case. But that's sort of unclean coding, right? Might be something to consider refactoring once we get it working. All right, so now we have to do this last part. So let's see how this goes. All right, so here's what it looks like now. This is here, this is here, this is like this. Okay, so it looks to me like things are as expected. I keep using we. Why am I using we? Okay, so as if I'm talking about me and the computer working together. I guess that's the idea, but no, let's just say I. All right. Sure. So let's see what happens when we put our puzzle input into here. Okay, so the short one is up here. Let's put that in. Cannot read properties of undefined at solve2. Okay, so I messed that up. Reading 0 at 17. Do I want to prettier this? I think the formatting looks fine. Where do I think I'm reading 0, though? So I went 0, 0. All right. So is it reading 0 here, or is it reading 0 where? So that shouldn't be undefined. Which one do we think is undefined? Empty space? Ah, yes, I didn't handle the case. Yep. I completely left that out. So I didn't handle the case where there is no empty space. So this is all going to be if empty space, right? So if there is no empty space, we just move on. Okay, so did anything come back? No, it hung. Darn. So it is very slow, huh? Even on this small one. Or it's just not working at all. 4. So we plus I here. So I also, there's another case that I didn't handle. Let me copy this, because I'm going to have to close this out. Let me go ahead and close this out. And close these. Okay, so now here, let me open up AOC4JS. Copy this here. So this is going to be if file sub 0 not equal dot. So now let's prettier. And cat. Yep. Okay, so now let's go back to AOC where I was. And let's return here. And let's run this again. So here's what I've got. And so, yeah, so this is what I had left out. The file has to be like this. Otherwise, we just need to move. The file has to be not empty space. Otherwise, we just have to move on. Okay, let me try it again. I think that was likely the problem. Do I need another console log in here somewhere? Probably, yeah. Let's throw in a console log for the file. Okay. All right, so I'm looking at empty files, so that's clearly never going to work. Let's stop this again, and stop this again. All right. So if there's nothing in there, we need to just move on. I think that might be all I need. Let's prettier again. Okay, so I got a number, but it's not correct, right? It's, yeah, it's supposed to be a different number. So let's put a console log here. I'm trying to half-baked do this one. Okay, so this didn't come out anywhere close to correct. It's completely effed. My 9s are gone. Everything is completely effed. Darn. Ah. All right. Okay, so let me see, where did I mess it up? So, like, it sort of looked like it was working when I sort of ran through some of it, but clearly it is not actually okay. Okay, so let's not do this, because we think it's okay there, I believe. Let's not do this. Let's just do right here. No, hold on. At the end of each loop iteration, let's see what it looks like. Okay, so here's how we started. Ah, I put a 2 in there. Wait a minute. Okay, so at the very beginning, is it correct? No, it isn't. What is this 2 doing here? Oh, I have to JSON stringify it. The way it comes out in the console actually gets modified after the console log. Okay, so all right, so here's how it looks. 0, 0, 3s. Okay, so far so good, right? All right, so then we moved the 9s over to here, and this is reduced, so that actually looks right at that point, I believe. I've got a dot here. That shouldn't really matter, right? Okay, so now this happened 4 times apparently because so why did it happen 4 times? So we did 1 change, then this requires no change, this requires no change, this requires no change. So then the next change should be this. All right. So we moved the 7s. Okay, so first of all, this is actually not right. When we moved these 7s over, we actually do still need, and I didn't realize this until just now looking at it, we actually do still need 3 dots there to show how much empty space is there, because we're going to need to know where these are in the file system to get the checksum correct. So let's make that change first of all. Okay, so how's that? So number's still not correct, but I put 2 dots here where the 9s were, so that's more like what it needs to be. I put 3 dots here where the 7s had been, so again, more like what it needs to be. Are the 7s in the right place? No, they are not. The 7s are in the wrong place. So I left out some other logics. This is one that had been on my mind, but slipped my mind. So here, we have to increment, so let's see. So we inserted 1 into the empty space. So actually, all of the empty spaces have to be offset. So instead of doing this, I'm going to say offset equals 0. And then we are going to say I plus offset here. And so then I'm going to make a note. Offset representing the amount of change made to file system by splicing. All right. So now this is going to be plus offset here. All right. So now we increment the offset. So now the comment is not accurate and it's not really needed to explain because I sort of explained here. And then here we add the offset. And here we add the offset. Nope, that won't work. That won't work. The offset can only be added to the ones that are after where we added, not before. Darn. So using this empty space array is just overcomplicating things in a way that I sort of imagined would be okay, but now I see is very much not okay. So we don't want to use empty spaces at all. So that's not gonna be useful. I might actually need it for performance later, but for now let's do it without. So the empty space is now going to be file system find E, and it's going to be E sub 0 equals dot and E length greater than equal file length, right? So I can call that empty space, but now it's going to be used differently. So this becomes the index. Oh, I need to put the index on there. So we won't use it here. We want to find the index because we're going to need it. And find index is -1 if it's not there, I think. Yeah, -1. Okay. So then here, we just use the empty space index. All right. And so now I don't think we are going to use an offset, are we? I think I just have to increment I like before. So no offset. So we don't need to do that. That's no longer a concern. So file system empty space index length subtract file length, right? Okay. So it's like that. Let's look over it. So got rid of the empty space. It was overcomplicating things, I think. So now this is completely straightforward here. We don't have an offset. Let's get rid of that. We'll find the file. We'll check to see if the file is an actual file, right? Then we will say that we are going to find empty space of sufficient size to put the file there. Here's another problem. So we do not want to move a file to the right. So let's make sure we are not moving a file to the right. Okay. We only want to move them left. Also, if there's nothing here, then this is going to complain. So we have to say length. So let's do the length check first. So we'll get rid of it here. So we'll first check to make sure we haven't overshot because we don't want to move it right. Then we'll check that there is enough, we'll check that it's big enough, and then we'll check that it's empty space and not a file. Okay. I feel like that actually could use a comment. First, check that we're moving to the right, not left. Then check that the item is big enough. Then check that the item is empty space and not a file. Okay. So that's what we're doing here. Now this is a good jam. This is classic. Okay. So let's move these comments. So this one will go here. Then this one will go here. And then this one will go here. Okay, first check that we're moving to the right, not left. Then check that the item is big enough. Then check that the item is empty space and not a file. All right, and then let me close that. Okay, there we go. So if we did in fact find something, so now I have to splice the file into the file system. So we do that here. Then remove the file from where it was, which we do here. Then reduce the length of the empty space by the length of the file. I feel like it might make more sense to do that first. Let me move this up. So do that before splicing. So I'll say first I reduce the length, and I can use First, reduce the length of the empty space by the length of the file. Okay. Then, splice the file into the file system at the empty space. Finally, remove the file from where it was. Okay. Increment I because we spliced to its left. Okay. So I got the 2858, which is correct. Let's see if these came out as we expected. So we got the 99, we moved it over here. Then we didn't move the 888 because the 48s because there was no place, but we did move the 7s. We moved it over here. That's where they go, right? And we can see that here. We moved the 7s over there between the 1s and the 2. There's an empty space here. That's not going to affect anything once we flatten. We don't move the 6s and we don't move the 5s because there's no room for those. 3s either, there's no room for them. But the 4s, no. What do we move? So we moved the 7s. Then what do we move next? The 4s. Okay, yeah, we scooched the 4s. And then this is our final answer. So we scooched the 2. Okay. And we got 2858. So I think that's right. Let me throw that into Prettier one last time. Wait, where is it? Right here. TypeScript language server. Sounds like a winner to me. So let's Prettier that and grab it again. Copy. Okay, so this is what we've got. File number. Okay, let me remove the logs now, since I think it's correct. Okay, let's solve again. $28.58. All right, now let's see what happens when we go for the big one. Okay, so if we look at this, do we notice any trouble spots that seem super inefficient? I want to say I think it's probably okay, but I don't know, man. I don't know. Let's try running it. Okay, where is my puzzle input? Put it in there. So, oh, it's solve 2, not solve. Pretty slow, so we do need to, yeah, we do need to improve the efficiency. So previous answer equals this. All right, now let's go back and redo solve 2 so that it's not so inefficient. Because we can't be having like delays like that. A user would be like, what's happening? It's not working. And it's true. It's not really working. At least it's not working correctly if it's taking that long, right? So where are we taking all the time? I want to say it's got to be in the big for loop. It's got to be, right? So find index. Shoot, that's got to be a problem. So this is part of the reason why um I wanted to have that array of the empty spaces, like with where their indexes are, was to like hopefully help to avoid this problem of taking forever. Because it's going through the whole file system every time to see if there is empty space, right? And that's taking forever. I think that's the big problem. Do we have any other? This splice is probably also slow. Yikes. I think this is the bigger problem, this find index. Yeah, I would say the splice most likely is slow, but let's try fixing this first, because I think this is more straightforward probably to fix, and I think it's probably a much bigger problem. So, is it time for me to take a brief break? I am going to take a brief break and walk outside. So while I'm walking outside, this is the problem I'm going to be thinking about. I'm going to be thinking, how are we going to find an efficient way to get this number instead of going through the whole array, right? Clearly, we're going to have to do some manner of pre-processing, right? So I'll tell you what I'm envisioning. I'm envisioning that we're going to have probably like an array that just has like how much space is in each empty space, so that we can quickly determine, oh, there's no space big enough, and then just move on. The problem is that we're going to have to keep updating it. Like if we keep splicing like this, we're going to have to keep updating that. So really, splicing like this is probably a bad idea. What we can do instead of splicing like this is we can take this. So this is an array. So we can just modify this array instead of splicing the big array. And I think that'll be a lot better. And so then if I have sort of an array indexing where these empty spaces are, then it won't be so hard to update them. All right, so I'm gonna walk outside for like 5 minutes and think it over. BRB. All right. All right. I thought about it and I decided to give up. It is a good problem. It is absolutely something I need to like be able to solve. It is solvable, no doubt about it. For sure. But there are other things I want to do. That's my excuse for everything, right? If it accepts this, I'm gonna say I'm gonna just move on. I'm gonna put a pin in. I'm gonna put a note. Let me open up the Discord. I'm just gonna put a pin in it somewhere. Advent of code. To revisit, can you guys read that? To revisit AOC 9 part 2 to do it again so it's not so slow. So slow. I shouldn't put it here. I should just put this in my own. Let's put it in my own. But for now, I am forging ahead to exorcism again. Okay, so let's close that. I can close that too. All right, let's look at exorcism. I'm hoping that they might have dropped the last week. I don't know when it's supposed to drop. No, it looks like we're still on 47. Let's look at what diamond is, right? So diamond is the last one to have been dropped, and then there's only one more. I thought the Ren syntax looked very, very nice. So let's try it in Ren. So let's go over here. I want to try it. I think I should be able to knock out like 6 exorcism assignments today. If I do 6, I'll be very happy. And then I would like to go back to what I can never remember the name of that weird site. Java Scriptmas Scrimba? I keep wanting to say like Stigma or something. Scrimba. How hard is it to remember the name of Scrimba? Scrimba. Okay, I'll try to remember it. So yeah, there's already, so I did 1, but look, there's 8 more that I haven't done. That's exciting, right? Scrimba. Okay, so anyway, I want to knock out like 8. I said 6 before, right? 6 is what I'm thinking. 8 would be great though. 8 would be amazing. So let's go to exorcism. Ren. Okay, so this one is called Diamond. So let's see what Diamond is about. Actually, I think I did look at it. It's some weird text thing. Let's see what it's about. Okay. The diamond kata takes as its input a letter and outputs it in a diamond shape. Given a letter, it prints a diamond starting with A, with the supplied letter at the widest point. Okay. The first row contains 1A. The last row contains 1A. All rows except the first and last have exactly 2 identical letters. All rows have as many trailing spaces as leading spaces. This might be 0. The diamond is horizontally symmetric. The diamond is vertically symmetric. The diamond has a square shape, width equals height. The letters form a diamond shape. The top half has the letters in ascending order. The bottom half has the letters in descending order. The 4 corners containing the spaces are triangles. Okay, so good, right? Okay, let's take a look. All right, so right here. So we'll say if letter equals A, return A. We start like that. Could not load. So we're supposed to go ren c install. What's the help? Ren c help. Ren c shoot. What is it we're supposed to do? We're supposed to go ren c package ren. Okay, let's try again. Expected an array. Okay, let's take a look. All right. Only 4 more tests, apparently, so let's do the second one. Okay, so A is fine. Now we wanted B. Okay, so if it's not A, can we decrement the letter, do you think? Let's look at that on Ren real quick. That's C++. Okay, so string class. So we can do from code point. We can do code points. Okay, so they did string code points. They put a 0. Okay, this is string. And they did a 40. Okay, so let's take a look. Smaller equals rows. So we're going to pass in letter code points sub 0. And then we're going to go from code point. No. Yeah. Static. So we're going to go string from code point. Okay. Whoops. And then we're going to decrement this. Okay, cool. And then we're going to try mapping. So sequence. So we can do a map. Cool, cool. Looks good to me, baby. So we're going to return smaller. No, hold on. Bigger equals smaller map. And then we're going to put S, because each one is a string. And then do we have like string interpolation? That's fine. We have concatenation though, right? So we'll use plus. Okay, so we'll say okay, so we expand it that way. All right. So now we need to duplicate the middle row. Okay, so let me put that as a comment. Now duplicate the middle row. So let's go back to sequence. So we can like slice these, right? It's showing it somewhere. Let me look. Okay, so map. Take. Where. Okay, so syntax for maybe a list. Yeah, so we slice it like this. Great, that's lovely. Okay, so start equals bigger, and then we'll slice by going, so is it one indexed? It's not one indexed, is it? So it's going to be 0 through, and then where's the length? So we'll divide 2 there. And so then is the slice inclusive? 1 through 2 looks like yes. So I'm thinking we want to subtract 1 here, and then middle equals bigger sub. Okay, so let's say middle index equals bigger count over 2. Middle index subtract 1. Middle index end equals bigger middle index plus 1. And then so here negative bounds can be used, so -1 is the end. Okay. Love it. Okay, so now we have to put spaces in the middle, right? And then, so the question is how many spaces to put in, right? So spaces to add equals middle count Wait, it's a string, right? So we need the string length. It's count still. Okay, good. Count -2. Okay, so now do we have like a repeat? Amazing. Amazing. So now we'll say new row equals space, or let's see, so equals letter plus space multiplied by spaces to add plus letter again. Where's my plus? Plus letter again. There we go. So then we will return. Okay, so now when we do this, can we plus these things? Ooh, I'm not sure. Adding lists together. Yes, so we can combine them like that. Okay, amazing. So we're going to return start plus middle plus new row plus middle plus end. All right, so where do I think I have screwed this up? Seems simple-ish, right? Okay, what did I get back? Does not implement smaller equals. Okay, so I have to, so I haven't declared variables. Syntax variables, I think I just put var, right? Okay, so we put var. Okay, var, 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 var. Okay. Should have done them all at once. Map sequence does not. Okay, so map sequence is where? Where did it say it was? Does map sequence on what line? Map sequence does not implement square brackets. Okay, so can we ren c diamond diamond ren? And what did that do? Let's go to here. Ren c. Okay, so we can run the script. Okay, so now if we put a call in here and say diamond rows B and then ren C. Okay, so there it is. So line 21. Yay, line 21. Oh, wait. No. 12, there we go. Okay, so right here, does not... Okay, so bigger... Ah, so we used map, and then what happened? Map passed back something. So they put to list on it. So let's do that. Is that better? Range end must be an integer on 12. Is that any better? No, it says the same thing on 12. Range end must be an integer. Ah, this didn't come out as an integer, so let's find our integer division. I guess it's a num. Abs. Seal. Okay, so methods. Grab my scroll bar here. Okay, so usual arithmetic operators. So I think we just want floor. Okay. I think floor should be fine. Yeah, it should be fine. Okay, so it ran. How do we print? Getting started. Okay, so they did system.print, it looked like. Okay, let's try it. All right, so I got A. So no, that doesn't look right at all. Oh no! So I got A, B, B, A. All right. It doesn't. Okay, so there's one extra row in there, and the reason for that is what? So we did start, middle, new row, middle. So the intention was when we did 0 through middle index minus 1. Okay, so it was 0. So when we did minus 1, it came out as minus 1. Okay, so that's not going to work. So it did say it was a degenerate case, right? So I guess we can kind of see that now. So if middle index greater than 0, all right? So we'll do that. This can be moved up. This can be moved up. This can be moved up. Okay, error at, so it's on 25. Expect to begin method body. Error at dot. On 25. I think I just have something mismatched, right? Okay, so now it says A, B, B, A. I think that's more like correct. So let's get rid of this for now and test. Okay, so that's our degenerate case. Now let's go into the spec and do this next one. Whoa. Okay, that one's fine. This one. Good. Largest possible. That's fine. So now let's take a quick look and see if we want to refactor. Okay, class diamond. Static method, rows, takes a letter. If letter is A, just return this A. Sure. Then we do smaller equals all this. I think that seems pretty necessary. Bigger, smaller map to list. So adding those spaces, I think that is required. Now duplicate the middle row. Yep, that is what we do in this next portion. So I guess that's okay. I'm gonna put a blank line in there. Now duplicate the middle row. That's that section. So then middle index is this floor? I guess so. Do we use middle index quite a few places. We use middle here. Okay. Spaces to add is this. We just used that the once, but I think I like it that way. We mash those together. Where's my music? Where's my music? Oh, it's just quiet. Okay. End is that. Yeah, I think that's fine. So it's not really formatted nicely. Right, so these are at the same indentation level. Okay, so this is good. This is good. I just want to fix the indentation level, and then I think it'll be fine. It's just these two. Okay, cool. Test again, and let's submit. Okay, so that one wasn't too bad, I think. Uh-oh, it opened over there because I just clicked on my music. All right. So yeah, it wasn't easy for sure. This is what I got. Let's mark it as complete. Cool, so that's one. Can I do 5 more today? I should be able to, no problem. Because for this session, I intend to keep going for like another hour and like another 20 minutes. So another 80 minutes. And then in the evening, I'll do another 4 hours. So that should be plenty, but we'll see how it goes. Okay, so I think that Ren programming language looks really nice. I think it seems like a relatively small project, so it might be a little light on tooling, but it seems really, really nice to work with, I would say. Okay, let's go with something else. So that diamond kata is kind of cool. Should we try it in Teakle? I'm nervous. I'm nervous about both of these, so I'm going to try CFML first. I'm going to take a look. Something about it makes me nervous. Okay, so we're going to join the CFML track. I think it's going to remind me about the boot camp again. Nope, nope, not this time. Okay. Oh, it is. Our boot camp might be better for you. Honestly, that might be true, but I'm going to skip past that for now. So we're going to do it here. All right, so what is the tooling for CFML? So the only thing you will need is command box CLI and Java 8. Okay, so I don't think I have any such thing as a command box CLI, but let's see what this does for me. Command box. Let's see what we get. Looks like that's starting to work okay. And so then the next part, oh gosh. Let me close this down for now. Okay, so that's good there. Oh, is this that? This is that VPN? We can close this. All right. So good there. Oh, a REPL? Let's take a look. Oh. Huh. Libraries initialized. Cool. You can directly execute CFM pages. Interesting. You can start up a web server. Sounds handy. Interactive shell. Well, all right. All right. So let's try the hello world. Okay. It's box task run a test runner. All right. And then what is going to happen? Installing. Yes. Hit me with it. Hit me with it. All right. So cool. Let's now look at the file. So it's the hello world CFC file. Okay. Component returns a string greeting the world. Hello world. Pretty interesting so far, I think. So let's submit that. CFC. Okay, let's take a look. All right, one iteration submitted. It doesn't really show passed on this one, but whatever. Okay, I mean, it passed the test locally. So let's go to Diamond now. So we're going to close out of here and go to Diamond. Okay. Let's see what's in our stub file. Okay, your implementation of the Diamond exercise. We have a component. We have something that returns something, I guess. So array function rows letter. Okay. I'm going to copy my other file into here. So it was kind of a long list now. I mean, Exorcism like is really getting me to download a whole bunch of things, and I mean that's probably most of the point, honestly, of doing the exercise. All right, so where were we? It was Ren. All right, so we put that in here. So now let's comment out. Okay, sure. Okay, so let's start by saying if letter equals A, return A. Okay. Installing. Okay, okay. All right, so interesting. Wow, that came out looking kind of crazy, but all right, all right. Okay, so single A did pass. Amazing. So far, so good. I love it. Actually, I'm really happy with my introduction to this language. It seems pretty neat. So, let's try this now. So it looks like here we included like a data type. So do you think we want to say int here? Or do you think we want to say var? What do you think we want to say? So let's see. Let's take a look. CFML declare a variable. So this is Adobe apparently. I think I should have known that, but I don't think I did. So creating variables, let's take a look. So this is a Java related language apparently. You create most Cold Fusion variables by assigning them values. You must use the array new function to create arrays. Prefix each variable's name with its scope. Right. I guess that's cool. Actually, it doesn't sound very cool, but maybe it's fine. So UDF is a user-defined function. Interesting. Okay. So creating a UDF. Huh. So here we give an example. We give a function name, and it returns this end CF script. Huh. Yeah, okay. So we said var here. Okay, let's try it like that. So I'm going to say var smaller equals rows. Okay, so now the letter that comes in, so we did from code point, and then we subtracted 1 from the code point that we had already, right? So we presumably want to do something similar, I guess, here in Cold Fusion world. So interesting. User defined. Seems like this is a pretty big like framework, right? Wow. Convert case for array. Function converter. And so they passed in L case here. Okay. So I think we want to see like where we list the different built-in functions that are available, I would think. So we're going to look at Cold Fusion list of built-in functions. Yeah? Let's take a look. So the one we want is probably a string function, or maybe a char, but I'm going to say most likely a string function. Okay. So we're going to use CHR and ORD, I guess? Just like Python, I think. Where's O? Did I pass it? It's not here. So we have CHR, but what do we do to go the other direction? Converts a numeric. Val. Huh, okay. Val instead of ORD. That's fine. I think it's actually a little bit more mnemonic than ORD. I always remember ORD, but whatever. So we put val, a string or a variable that contains one. Oh no, this isn't it. This is taking, oh no, 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 no. Ah! So which one do we actually want here? Convert a new, so CHR, let's take a look. Oh, ASC and CHR, that's it, right? Ah. Okay, 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 cool. So, that's nice. So we're gonna put, and it looks like it's capitalized. Okay. So we're gonna put CHR, ASC, letter, subtract 1, like that, right? Okay. That seems fine. All right, so now the next one. Var bigger. Okay, so now we have an array. So array functions. Let's take a look. Array map. Iterates over every entry of the array and calls the closure function to work on the element of the array. So let's take a look. So array, callback. So this is how they do it in the example. So they have an array like this. They say map, and then they say we're going to have a function, and then it's just going to be return item. Okay, sure. CF fiddle? What? Oh, neat. Okay, so if we hit run, what happens? Oh, wow, look at that. Can we see that okay? It looks really small. But yeah, that's pretty neat. This is interesting. So we're going to do basically the same thing. We're going to say array map. We're going to put the smaller in there. And then we are going to put a function. And it's going to be a row. And then in the function, it will say return. And then it will be plus row plus this. Yeah? Okay. I'm going to start listing the songs that I'm going to take off my playlist. Like, this playlist gets really repetitive. There's supposed to be over 300 tracks on this playlist, but it's not enough. And this one is coming off the playlist. So this one is called, I'm going to start listing them on my paper here. So song. Okay, so this is called Songs to Remove from Playlist. All right, songs. And I'm going to put all of the good ones are. Not that I think it's a bad song per se, but I'm tired of it. All the good ones are. It's like, I think it's really the only sort of country song on the playlist. And I would feel more comfortable just having 0 country songs on the playlist. Okay, so, um, so that part we think is probably okay if we just do like this. Oh no, I need to put equals. Equals. Okay. So is that similar? So they went new array equals array map. They did put a semicolon here. Apparently the semicolons are optional. It's sort of a JavaScript-like syntax, I believe. So I haven't been putting semicolons up till now. I'm going to leave them out for now. So we did that. Now duplicate the middle row. Okay, so we're going to say var middle index equals. Okay, so bigger is an array. And on an array, we should have a len. So we're going to say array len bigger. All right. And then we're going to divide by 2. But then we need to know when we do a division, is it going to be integer division? Let's see. Cold Fusion arithmetic integer division. Okay, let's take a look. Modern Cold Fusion. Let's go back to Adobe. Okay, so here's Adobe. So it says that they used a backwards slash. What? Okay, that's cool. So we'll use a backwards slash. Amazing. Okay, so now we'll say var middle equals, and that is bigger sub middle index. Okay, I think it kind of makes sense so far. Then I'll say var spaces to add equals. So middle is a string, so we can't do array len, we want string len, right? Centers, hash, len. Okay, so we're going to say len, and then we're going to say middle. Okay. And then we're going to say new row equals letter plus. Okay, so now do we have a repeat? Repeat. And let's take a look. So I think we just put in a string and a number, right? Okay, amazing. So repeat string, and then we'll say letter, no, space, wait, yeah, there we go. Space, spaces to add. There we go, and then put letter on the other side of it as well. Amazing. So then we'll say var result equals, and I'm going to say middle plus new row plus middle. Okay, and then return results. Okay, let's run it. So we had 1 passed before. Oh, still 1 passed. Darn. So what does it say in this case? It says can't cast empty string to a number value. And that is something that we tried to do here, I guess? Interesting. Or, let's see. A number value. It's because I'm trying to use plus. I need to use a string concat. What would it be? It's probably something in a pretty basic area. Okay, so in string functions, we want to join, we want to concatenate. Where's concatenate? So I don't see concatenate here. I feel like it's a string operator, so we're looking at cold fusion, string concatenation. Yeah, just like that. How do I concatenate? Okay, yeah, let's take a look. And, okay, cool. I am totally fine with that. So we're going to say and instead of plus right here. Okay, so it might very well be that concatenating arrays may not work with plus either, and it might have to be and. It says this is string concat, but let's just see what it says when I do this. So it's probably just one passed still, because I still think that those plus operators are probably wrong. But what does it say? So when we get to here, array index 0 out of range. And that was here, right? Okay. So array index 0 out of range, array size is 1. So are they 1 indexed? It's totally fine if they are. It must say that somewhere, right? So I'm going to say, note that I suspect that the cold fusion arrays are 1 indexed. I don't really know, but let's just try it. So if they are, then adding 1 should help, right? So let's see what it says. Okay, so now it says can't cast. Okay, so we made it past that point. So now on 25, can't cast B string to. Okay, so it's because we're using the plus again. Oh, okay, okay. So we need the and there for string concat for sure. I had missed that before. Note that operator is string. Okay, so do we make it past 25? Let's see, let's see. We made it to 27. Okay, so here I tried to use a plus, can't cast complex object type array to a number value. So now I'm guessing that we probably concat here using one of these array functions, I think. Array append, that's an element to the end. So we want to, concatenate to two different arrays, right? So average clear contains delete each filter find last len map max new prepend. That's an array element again. Array set. Slice sort sum swap to list. Oh. Okay. So it does say that I have an array, right? Okay. So let's look up whatever I looked up here. Array. And, if I don't see anything right away, I'll just... Okay, here we go. Join two arrays in Cold Fusion. Just use Java. Okay, so this is a little odd. So if this does work, then I'm going to want to make sure I have a link to it. Shout out to here. Okay, so now we're going to try... Okay. Did we get past that point? Let's see what it says. Add all does not exist in the Boolean. Boolean doesn't exactly seem right to me. Okay, so we don't want to do that. This is dumb. I think that literally all we want is new, no. We want middle, new row, middle. That makes a lot more sense. Let's see if that's right. No. So now it says expected A BBA, but got A BBA. Oh, interesting. So I ended up with too many spaces in here. Oh, yep. That is something I wasn't even thinking about. So why was middle... Oh, I subtracted 2 here, and I forgot to do that here. That was a bit of an oversight. Let's look at this one. Okay, so now 2 passed, so now we do the other cases. Okay, so in the Ren code, all of this is working. So now we're going to do this next part. So if middle index greater than 1 this time, because they appear to be 1 indexed, okay, so here we are going to say start. I don't know if we can quite do this. Let's see. Let's look at our array functions again. One of these is going to help us. Probably. So array functions, I think we just want to like insert at, probably. So we have this array. Now we insert at, so we look for 1, 2, 3, 4. So should it come after Tokyo? Wait a minute. Let's see this in the fiddle. So run. So it was London, New York, Paris, Tokyo, Barcelona. So Berlin ended up here at number 4. So, okay, so after Paris, which was number 3, they're 1 indexed, and before Tokyo, which was number 4, but is now number 5. Okay. So then we're going to say array insert at, we're going to put in bigger. We are going to put in the number middle index. And we are going to put in middle. Okay. Then we're going to do that a second time, but in here, we are going to insert new row. And then return bigger. Let's see. Nope, still failed. Okay, let's look at what is the first failure. So smallest non-degenerate expected A, BB, CC, BBA. Okay. Received BB, CC, BB. Okay, so that's not good. I think, yep, this should be, let's see, if middle index greater than 1. Okay, interesting. So it looked like I still ended up returning the result there, I think. So what was the middle index in that case? Wait a minute. Is that what I just read? I think I completely misread it. Oh, I was very much in the wrong place. Let me clear and run it again. Okay, right to the top. Okay, okay. A, B, B, C, C, B, B, A was expected. A, B, B, C, C. Uh-oh, I have an extra BB here. That's madness. Okay, yeah. I actually legit forgot about that. Okay, let's see. I think that might actually be it. Nope. All right, let's see what we've got. Darn. Okay, so A, B, B, C, C, B, B, A. C, C is in here. Darn. Okay. Okay, so that's in the wrong spot. Oh, I inserted them in the wrong order, didn't I? Okay, this is real code monkeying now. This is code monkeying madness at this point. But yeah, they did pass. I'm gonna submit. I will say this Cold Fusion language has made a really good impression on me. I did not know what to expect, and it seems awesome, actually. It seems pretty awesome. So I'm gonna mark as complete. Okay, so let's close these down. These docs actually seem very good too. I'm pretty impressed by this Cold Fusion. So like, let me just take a quick look. Cold Fusion. So this is a rapid web application development platform from 1995. Holy moly. Okay. So it looks like they have supported a new stable release 12 months ago. Wow. So What's happening with this in the 2020s? As of, so 16 updates. Okay. Oh, GCP. Huh. 2023 seems a little late to be adding support for this. Um, maybe, I mean, not better late than never, obviously. Bug fixes. Oh, cool. You know, probably they weren't really necessary because they just weren't using them, right? They used their own, like, system, but adding support for this, I guess, made sense at some point. Cloud storage. I think it seems cool. So I'm really happy that I was introduced to that. It seems like a cool language, I think. So let's try the TECL, I guess. I'm nervous, but I don't think it'll take long. Okay, so let's take a look. So we're gonna go to the TECL diamond. Okay, so I'm going to copy my ren file in again. So this time it goes into my diamond TECL file. Pronounced tickle or as an initialism. Should I say tickle instead of TECL? I guess that's what Wikipedia suggests. I don't know. Maybe they're trolling, though. You think they're trolling? Ousterhout's original 1990 Usenix paper did actually specify the pronunciation as the word tickle. Well, fair enough. I feel like this guy, I think this guy must be talked about in that one book, the data intensive architecture book or whatever it's called. I think I've got it here. I think that's likely where I feel like I recognize the name from. Oh, it's here. Okay. This book, right? By Klepman. So it's quite a famous book. I think Ousterhout was name dropped in here. Let me see. Nope, I don't see him in the index, so I think he would have been in the index if he was in there, so I guess I was wrong. All right. Okay, so SQL comments. All right. Okay, so we're gonna use an if. The Lang wiki. All right, looks good to me, baby. So we'll say if. And then what about return? Okay, so I'm going to return this. Okay, let's see. All right, so we put A, return code was 1, return code should have been 1 of 0. Invalid bare word letter, oh my goodness gracious. Okay, so if letter, all right, so we can't have a letter like this. We have to say Teakle use proc parameter in body, I don't know. So proc creates a new procedure. So here we have arg1. Okay, so now here I think we have to $arg1, right? Okay, so let's try it with $. It says invalid command name A. Okay. Teakle is kind of different. It seems nice, but I'm definitely not accustomed to it. So set value. Here comes an error. So let's see. Teakle quoting. Set value. Teakle string equality comparison. Let's take a look. Okay, so let's try it like that. So I think what we're saying is we're going to say string equal, and then we put these two. No good yet. It says in expression string equal $letter A. So invalid bare word string. Oh, shoot. So, okay, so we put them in square brackets. It does seem a little bashy, right? Okay, so now we said return code was 1, invalid command name A. Okay, okay. So now, do we put $1 on here? So we did not get any result that time. Still no result, darn. So here we returned a number. I still don't see any result. Dash result here. Code error, too small. Okay, what was in my other file? We did acronym. Acronym. So here I set, and then I returned. I think I kind of like Teakle. Like, I don't understand it at all, obviously, but I think it's kind of fun to flounder with compared to others. Okay, so let's say I'm going to set result Still don't see any result here. That's messed up. So I put 1 there. Isn't that true? Oh, what do I have $1 here for? That was just a guess. And it doesn't seem to have been valid. So they are equal. Oh, it passed. Okay. I guess that's all right. Okay, so now what? All right. So we did this. Okay, so when we use a proc, tickle ord char ASCII code. Scan. Hold on. What is scan? Okay, we'll see if it helps. Okay, so the %C, a single character, its Unicode value is stored. Okay. Okay, oh, of course. Invoked from within. Okay, so let's look. Tickle proc recursive. Yeah? Okay, so they have the proc here. So recurs is here and here. This thing looks crazy. What kind of numbers does this give us? One, two, let's try it with like 11. No, let's try array 2D n fill map okay. Let's say map. Oh, wow. Okay, so it is a wild one. Okay, so if it's 1, can we do that? All right, so what gets put in there? Just a 1. All right, so if it's 2, we get 1, 2, 2, 3. Okay. If it's 3, we get 1, 2, 3, 2, 3, 4, 3, 5, 7. If it's 4, 1, 2, 3, 4, 2, 3, 4, 5, 3, 5, 7, 9, 5, 13, 29, 61. So this is an obvious case where we could get much better results if we memoized, right? And it's already maximum call stack size exceeded at 5. That seems nasty. So let's define it with memoizing. So it's still okay. So it's still max call size, call stack size, even with trying to do memoize, I guess. Maybe I did the memoize wrong. Let's see. So now let's not do this. Interesting. Huh. That's a little goofy. Okay, so 3 is 61, 2 is 29, what the? 1 is 13, 0 is 5. Huh. Interesting. I guess that number must get crazy high though, huh? Wow. So what in the world? What in the world is this? Ackermann function. Mine isn't that high, is it? They said it's 4.2? No, mine's not that high. Oh wait, maybe it is. Shoot. Huh. Oh. This one's crazy for sure. All right. So, I'm way off. I'm way off in the woods now. What were we trying to do? Okay, so it was supposed to be recursive, but we couldn't. Okay, so it seems to me that we probably are not able to do it recursively, and if so, that is probably just fine, right? So in reality, all we need to do is keep incrementing this diamond letter. However, it's getting to be close to time for me to stop for now and come back in the evening. So this one is marked as easy, but it doesn't seem easy right off the bat. I mean, it should be. What I could do is like just do it in a different. TECL is a little bit confusing for me. I could try doing it in a different language with just, you know, a non-recursive implementation. For now, though, I think what I want to do is I do want to go look at Scrimba. So I'm going to preview Scrimba, and I'm going to try to do one of these. Actually, I'm going to try to do 2 of these this evening. All right, so JavaScript Miss. I'd like to do 2 of these. I would, actually. So one of them is Ugly Advent Calendar. I don't like the way these are presented, honestly, with the video. Like, that's weird to me, and I find it off-putting. But I found the actual, like, what am I trying to say? How do I get rid of the video? Escape? Escape? Okay. Oh, shoot. Escaped too many. How does this work? Okay, so challenge. Okay. I find the video off-putting, but, sorry. I did find the challenge last time to be quite enjoyable. So what's the deal here? All right, so here is an advent calendar, I guess. We can refresh, I suppose. Open me. So they don't work. So what are we asked to do? Oh my gosh. What are we? Not gonna lie, I do find the video presentation like really off-putting. Maybe it's just the easier way for them to put it together. No, I'm not sure I want to skip. Okay, so we want to be able to open these, I guess. So what do we think is going to happen when we click on these guys? It should change into a gift, right? But I don't think we really have gifts listed anywhere, right? Do we have some in the CSS? No. Sure. I see. Well, actually, I don't really get it. It does seem like a good exercise, I think. I don't think I really know any UX. What did he say? UX design fundamentals? Is that what it was? UI design fundamentals. This is the reason that I'm bothered by like video presentation. Because like if it were text presentation, I could just see it. But with video presentation, I have to keep going back, you know? Yeah, I've never been a fan of video presentation if I'm trying to like follow along with something. Um, yeah, so I am gonna stop here. So did I really just finish these two? I went into Diamond and finished these two. So I want to try and finish 4 this evening, and I don't know if I'm gonna go back to Scrimba. I had a fun time with day 1. But like UI design fundamentals, like I don't think I've learned any such thing, honestly. Hold on. Okay, so in the hints, color search Christmas for color palettes. That's not palettes in this context has just one L, right? It's a reference to a painter's palette. Okay, so some basics on accessibility and learn how you could improve the accessibility of this page, specifically regarding font sizes and color contrasts. I probably should have looked at the video for day 1. They probably would have revealed more information in the video. But like, yeah, basically, I would say like we don't love these colors obviously, so I would maybe start with some of these colors. Um like let's see. So it's a Christmassy color, that's good. So yeah, let's do what they said and look for a color palette here. Okay, so this one looks Christmassy. So let's make sure we grab all of these colors. Wait a minute. Okay, here we go. Okay, so we'll use a color like this. These look very close to me. On my monitor, these are quite hard to tell apart, to be honest. So I probably just want... it's fine. I can do both. Poison Ivy, Bright Light Green, Cathode Green, Mordant Red 19, and Danger. Complementary Harmony. You know what? I want one with white in it somewhere, and also like something darker. I like this one, so maybe let's start with this one. But also this one, I don't know if I can just mix and match willy-nilly though. Let's start with this one. Okay, so we copy that, and now in our CSS, we go, we define some, so I'm gonna say, Xmas white. Now I don't remember so you have to say var. Let me remind myself, I haven't done this in a while. CSS variable. Custom properties. Okay, so we do... A common practice is to define custom properties on the root pseudo class so that it can be referenced globally. Yeah, let's do that. Root. Okay, so then we just put them with 2 minuses. Okay, so minus Xmas white. And then paste. Does that seem okay? Do they need dashes in them? I don't think they do. So then dash Xmas red. And then we grab that here. Oops, I just closed it. Let me find it again. Okay. Copy. I keep fat fingering. Okay, so that's my posture getting me. Okay, so Xmas green. And Xmas mint. Right? And so then wherever we have a color, let's make this one Xmas red. Oh no, let's make this one Xmas red. Oh wait, when we do it, so when we go to get it, we have to say var, I think, right? Or something like that. Yeah. So this one might be like the pink. And then for... So that's a color there. Where's our next color? So tomato for the calendar container. I don't know about that. Calendar box is just plain red. Oh, that really looks bad. That really looks bad so far. Oh no. Okay. And then the text color, let's say, is var Xmas white. Oh, that's actually a little better. That's actually a little better. And that was the last color. Okay, let's see what it looks like now. Yeah, I actually do think that seems a little better. So I used the Xmas pink, the Xmas red. It was really bad until the white kind of brought it together, I think. Okay, so using the Comic Sans seems pretty senseless. So let's choose something from maybe Google Fonts. Something cute. How about this one? So get. So we'll copy this into the HTML file. All right. I do need to stop here. I'm probably going to lay down for like 30 minutes. Then we'll grab this. Okay, so then which one do we want to use for that? Probably this heading up here, right? So we'll take this and put it here. Okay, how's that look? Oh, it didn't change. Font family, let's run. Yeah, that actually looks cuter. Cool, cool, cool. All right, so does it suggest one to pair with this one? So we picked Delius. I think it's sometimes often used to suggest pairings. So if we go back, so we selected this. Figma pairings. Hold on. So we chose Delius. Wait. Okay, Delius right here. Choosing type. And then yeah, appearance holidays, lovely. See, these tags are nice. So do they have commonly used with or something like that? I think that at some point they might have gotten rid of whatever commonly used suggestion they used to have. Okay, let's look at pairing here. I'm not gonna mess with that. I'm just gonna pick one. Okay, so let's clear this. And let's choose a filter. And we want holidays. All right. But this time we want one that's more for readable, smallish text. Oh yeah, let's choose Christmas. And let's choose a serif Christmas font. Let's do this one. All right, so now this was added, right? So we still have Delius, and now we added Playfair. And then CSS class for variable style. Or, oh, interesting. Optical sizing. All right, let's grab that. And then, so I think I want this one for the, this guy, the calendar. It doesn't look that good, I don't think. Darn. I'd have to choose a different one. All right, I'm logging off for now. And I will come back in 1 hour. Oh wait, that didn't, why is it like that? Font variation settings, WDTH? Why does it say that? I don't know what font variation settings are here. Let's get rid of it. And then this, we'll choose 600. Is that any better? Not really. The colors overall, I feel like are improved. Can I do this same color for the H4 maybe? Can I do... Maybe make this one larger. I like that a little bit better.